Hello. Set up chat really quick. And then okay. Hello. I keep moving my camera around. Just keep it. Mute this so we don't get redundant audio issues. And then we'll get started in a second. Everybody's doing all right. It's Tuesday at 1. We're going to be doing geometry. We are continuing with our unit about circles and area. I want to talk through the chapter summary really quick first. So I hope everybody's doing well with quarantine, not going out and seeing people. You're having a good time and you're connecting with all your teachers. Remember, you can email me or send me reminds. I did not grade this weekend or yesterday, just puppy stuff and busy. I'm tired because not sleeping. So I will get caught up on those things. So if you have stuff, send it to me. And that should get put in. Remember, tests and assessments, quizzes, if you want to retake those or change your grade, what you have to do is put in a Khan Academy test that's close. So if it's the unit about trig functions for geometry, go to the geometry section, find sine, cosine, tangent, take that unit test, and then write a study guide. I think you should write the study guide first. I know I said them in the other order, and I kind of regret doing that, but you should put in the study guide first, email that to me or send it to me on Remind, and then take the test and tell me that you've taken the test, and we'll get those put in. Okay? So that's how to retake assessments, make up assessments, that kind of thing. And right now we are in chapter 11. Right, so we skipped chapter 9, which is all about circles, chords, and all that kind of stuff. And we're going to chapter 11, which is more about volume and surface area, 3D objects. And we're going to get started talking about the chapter summary. That's in the Dropbox. You can look at that. We're going to go over some of it. We may add some more stuff to the Dropbox, like the student journal, if you want to do extra practice or see those problems. And remember, if you have any questions or want to talk to me while we're doing this, the chat is there. So you can, all 7 of you. Sorry, I got to move my computer camera. I'll talk to you. Pop this out. That. So if you want to communicate with me, just talk in the chat and I will see it eventually or get distracted by it. Creativity. Okay? So first thing, chapter summary. Not that button. That button. Looks like this. It's in the Dropbox. And we're talking about circumference, area, and volume. Something that we're going to assume is that you remember some of the formulas from 8th grade, which may or may not be true. Right? So we'll go over those formulas. We're going to talk about surface area again today, just as a reminder. And we'll talk about circumference and circle area today. But here's a bunch of vocab and things that we're going to want to be able to do. Okay, we're going to want to be able to use a bunch of formulas. So if you look at these learning goals, there's a ton of these that are use formulas. Right? Use formula, use volumes. It's using a formula. Okay? We're going to be looking at a lot of formulas, plugging in variables. Here's some vocab, like we've got circumference, the area around the circle, right? And we've got arc length and solid of revolution. This is when we rotate something, and if we remember all the pieces of the rotation, then we have a solid shape. We won't use all of these things. We're going to use most of them. Okay? And then here's the very helpful section. This second page has basically, in this section right here, every single formula. Oh, that's annoying. Every single formula that you're going to want to be able to use. Okay? So on Thursday last week, we talked about circumference. And it's, right, 2 pi r, or 2 pi r, or pi times the diameter, or tau times 2, or tau times radius. Sorry. So at 2 pi r, basically. So if you have the radius, you can find the other thing. And then we talk about arc length. We can use the angle measure to find the distance of the circle, or the distance on the circumference. So not the whole circumference, just a portion of the circumference using a fraction. Okay? So where did I go? Okay. So we're here. That's this. Okay. And we're here, and we have. My camera is not as good as it was last time, but it is what it is. We've got our circle and our radius r, and then we have this angle theta, this arc length a, or whatever variable. I think they use measure of arc rotation sometimes. That distance is going to be relative to the size of the angle and the size of the radius. Right? So our formula for that was back on this page, right here. The formula we talked about. Right, so that arc length, and we can rearrange that fraction to solve for different pieces, which is what we did on Thursday. Okay? Today we're going to talk about area. So circle area of a sector. So if you remember back to right here. If you remember back to 8th grade, we're looking at a pie, and we want to figure out, well, we cooked this pie, not just like a pie, but baked pie, pickle. If we cooked this pie and we measured the diameter, because we could do that, measured across it, and we just had a straight ruler, we could figure out how much pie there is. How big is our pie? Or pizza. If we buy a large pizza, how much pizza are we actually getting? We can compare that to the extra large and all that kind of stuff, right? So the area, the size of our circle. Oh, and that's a little. There we go. Our area is going to be. Area is going to be pi times r squared. Hopefully, you can do that. So remember, it's space. So like when we do the area of a square, we're going to do length times width. Right, so the area is going to be L times W. And here, the area is multiplied, right? So if this was in inches, our answer, this was 5 inches and this was 2 inches, clearly not to scale, we would get 2 times 5 inches squared, right? Inches times inches. And that gives us 10 square inches. So our answer for the area of a circle is also going to be in square units, whatever those are. So this would be units squared. Okay? Yeah, Naomi, you're going to send me the work. You can email it or you can send it on a reminder. I don't care. And you only need to do the Dropbox stuff if it didn't happen in class. We're doing this semester. Okay, so our area of our circle is going to be in units squared because this is radius squared, right? You can think of it like a square, right? But we have pi of them. In class, what we would have done is we would have done an activity where we take our circle, and I don't know if we would have cut it up, but if you look at your circle like this, here's the radius, here's another radius at a right angle. This area of this box would be r squared. And how many boxes do we have? Well, if we do 4 boxes, it's bigger than the circle. Right, each of these is an r. This whole thing would have been 2r, and this would have been 2r. So it would have been 4. The area of the whole box is 4r squared. Sorry, I'm writing kind of sideways because my thing's to the right. Here, the 4r squared, sorry, there's 4 boxes here, and that's bigger than the circle. So instead of it being 4, it needs to be the area of the circle area is going to be pi, which is, remember, 3.14 r squared. So it's less than 4. That would be because we subtract this area here, these little pieces. Okay. And that would leave us with the circle. Are we going to go with, we can, maybe. Yeah, we should probably do that. I can remember what they are. Might be a problem because I erased them off the board. Yeah, we'll get there. So area pi r squared of a circle. Now the thing that we want to do, because this was 8th grade. This was 8th grade. Find the area like that. What we want to do is we want to find the area of a sector. So our big goal is to find the area of the sector. Just like we found the length of an arc, we want to find the area of a piece of this circle. So like, well, half would be really easy, right? If we want to know half of pi, this is just going to be half pi r squared, right? Because that would give us half of it. But what if the angle is like 12 degrees, right? We want to do something different. So that's what we're going to do. Circle area. Oh, I'm sorry. Not circle. Sector area. This is going to be the ratio again between the degrees of the angle and 360. So we have our circle, and we have some angle, theta, and we want to find the area of this thing, this sector, this piece of the circle, the sector. And what we'll do is we'll take the radius, and those are the only 2 numbers we need. Remember, the total is 360, right? So there's 360 degrees here. We only need a piece of those. We need the theta. So our formula is going to be theta over 360 times pi r squared. So our total area of the circle times our piece of the circle, using the angle to find it. Sorry, I'm covering it. Okay. So for example, if we go back to this, sorry, I scroll down to 4. Here's that formula again. So I did the bottom one, this one here. Right. Area of sector, APV equals the measure of the arc, or the measure of the angle, divided by 360 times pi r squared. Okay. So, for example, we're going to do some of these problems. These are from the student journal, which you don't have access to. I uploaded this to So I think I did. Dropbox, so you can see the problems if you want. But we're going to do these down here. It's 7 minutes. Okay. So the area of the sector formed by angle PQR. We have 140 degrees. 140 degrees. And our radius is 4 centimeters. So our answer is going to be in centimeters squared. Because our radius is in centimeters. So what we will do is we'll go back to this screen. Like this. And here are our values. We have 140 degrees. That's this angle here, 140. And then 4 centimeters was our radius. And again, we're going to want to use a calculator. Yep, so we're going to plug these things in. So our sector area is equal to 140 divided by 360 times pi, just a number, and then r, sorry, not r, we're using 4. We'll plug it in. So, substituting. So 4 in here, so it's going to be 4 squared. And I strongly recommend you don't do any of the multiplication by hand. Okay, so we would go to Desmos. Go to our calculator. You could use Google, you could use a calculator by hand. So 140 times pi. If you just type pi, it'll put in pi. And pi times 4 times 4, that's 4 squared, and then we're dividing that by 360. The area of that piece of the circle is 19.54 centimeters squared. 19.54 centimeters squared. Which hopefully makes sense. Our total area is going to be 16 pi, which is much bigger. If we go back here, 16 times pi, like this. Whoa, not that button. Double doxing myself like that. Hotkeys only work on this screen. Nope. Run this. It's 50. Okay. So 16 pi is 50. So just a piece of that 50. The 19.54. The whole circle is 50.26 centimeters. Just the portion that we're looking at, this portion, not that portion, this portion right here, this little piece, is smaller than the total, right? I guess you can't see this. I want to do another one that's like that. So we're going to go back to the textbook. Okay, so we're going to find the area of the sector. So it's 8 inches and 70 degrees. Nope, not that. Sorry. So 8 inches, 70 degrees. And you could find the big circle area instead, right? It would be 360 minus 70, and then that would give us the ratio. And then we just plug these things in. So 70 degrees divided by 360 times pi, 8 squared. Okay. And so then we just plug that into the calculator, and that would give us the portion of the area. And you could find the large or the small. Okay, so this would be in Desmos. 70 times pi times 8 times 8 divided by 60. 39.009 inches squared. Okay, so that's bigger than the last one, but that's because the radius is bigger, and even though the angle is smaller. Bigger radius makes the sector area larger. Okay, that's finding the area of the sector. The other part would be finding the total area or the other pieces using the area of the sector. So here, here we have we want to find the area of the circle, and we know the sector area. Okay. So we're going to use the same formula, but we know the sector area, and we want to find the total area. Okay, so our sector area is 35 meters squared. This is a big circle. And the degree, the angle, theta, is 40 degrees. Then we have all the pieces we need, because we're going to plug them into this formula here. So this sector area is 35 meters squared. My degrees is 40. And we're going to use the same formula. We're going to substitute for this so we can find the radius. So you wouldn't need to find the radius, but we're going to do that. So 35 is going to equal this formula, because we know the sector area is 35, and we want to find this piece, this pi r squared. So 40 over 360 times pi r squared. And since the problem is looking for the area of the circle, it says find the area of circle V, we don't actually need to find the radius. We don't even need to find the pi part. So what we're going to do is we're going to solve for this whole thing. We're just going to leave this on this side. So to do that, we would multiply by 360 and divide by 40. We're cross multiplying basically. We're going to do 360 times 35. I multiplied both sides by 360. Divided by 40. Divided both sides by 40. And that gives me pi r squared. And we're leaving this because this is the area of the circle. And so we don't need to solve for r. We'll just leave it like that. And so then this is the piece we would plug into our calculator. This, which would be 360 times 35 divided by 40. 350. So the area of the circle, the total area, is 315. So the whole circle area is 315. The portion with this degree measure is only 35, but the whole thing is 315. And so then we can find the radius we want to do by dividing and taking the square root. Okay. Any questions so far? I'm mostly just solving for different pieces of the formula. Okay. Is that all I want you to be able to do from this session? It might be. region area. Yeah, that'll be the last thing. Region area. That's just adding subtracting areas. Right? Okay. Any questions about sectors or circle areas or any of that kind of stuff? Type them in the chat. You can give us like a hot second to think about all of that. And then I'm going to switch this back to this. Basically just plugging in and solving for different parts of the formula. Okay, so substituting, dividing, multiplying, all that kind of stuff. The last thing, so I'm not seeing any questions in the chat, last thing I want to do is, and if you have any questions, just ask them whenever and we'll address them, is combining areas of things. Well, you might need to watch back and if it's confusing. Which formula, Naomi? I don't know. The formula for sector area? It's in the one place to find it is in the Dropbox folder in the student journal page that I uploaded there. The other, or I will to that if I didn't, because I may have done it for algebra and mixed up. The formula is this. This shows up on the screen. This is the formula. Yeah, so that highlighted section is the formula. They're the same formula twice. That's why it says or. The other way to write it without the measure of the arc, because you might not want the measure of the arc, is to just use the like that. Is to just use the degree. So this is the angle. This is the angle here. We're using the angle to determine how much of the circle we're measuring, and then we're using the area of the circle, and we're just taking a fraction of that. So that's why we're dividing by 360. So it's angle divided by angle cancels out those units, but gives us a ratio, and then we're left with units squared to find the area. Okay, and that gives us a piece of a circle. So if you were fighting over a pizza with your friends, you could determine who gets more, what ratio everyone gets. If you want to just cut it into fifths or to 18ths, depending on how many people you had. Okay. Last thing I want to talk about is combining a bunch of areas together. Okay. So combining areas is just going to add or subtract to find a portion. So I need to go back to that screen. Okay, so we're going to find the area of a region. We're combining the areas together or subtracting. I don't know that I agree that I should use it. If you think of good reasons, then I might agree with you and I'll change my mind, but we'll see. Okay, so we have a region. I also don't think I could do this like camera thing. All right, so we want to combine some areas. In the picture, it looks like this. It's not always going to be this. It's like a dome thing. That's a circle. We have a rectangle. These are angles. I don't know if I want to hear you talk. I probably could figure out how to use the camera in the camera for Zoom. I don't. Yeah, I have reasons that I don't want to. You can type your questions in the chat. Okay. Picture that I drew, not super accurate. The lines are kind of crooked. It doesn't matter. There are two rectangles here, and then there's a half of a circle. Okay, and then we're going to label it like the book picture. I'm on page 605 in the textbook, if you're using the textbook. So this is 16. It's all in feet. I'm just going to put the different things here. This is 16 as well, so that's a square. And then this is 26. Okay, and then this is also 36 across. Okay, so things we want to find is how much paint would we need to fill in, and I want a different color. This, how much paint would we need to paint all that if this is a doorway? Okay, so we need a couple things. We need the total area. So the total area minus the two areas combined, the circle plus the small rectangle. So and by total area, I mean the big area. So this is going to be 36 times 26. So the whole space. Oh, I can't do it. That's why. So the area of the wall here, the big rectangle, is going to be 36 times 26. And then we're going to subtract half the circle. The radius of the circle is 8, and it's half of 16. I have no idea. All right, so 8 times 8 is the radius, so it's half times pi r squared. So half times pi 8 squared. Let me get my timer up. And then we would add this thing right here, the 16 times 16. Okay? So then we just simplify all that. We're taking the big rectangle, 26 times the 36, this thing, and we're subtracting out this middle piece right here to just get the green part, where the green part would be. Oh, fine. Okay. All right. So I'm going to do that on Desmos. So this, we go on Desmos, and we're just going to type it all in. 36 times 26 minus pi times 8 divided by 2 plus 16 times 16. You got it? I think so. This is a really big wall. 26 feet tall is very large. Okay? So our answer is 579 feet squared. Feet. So this. And our answer is in feet. Yeah, everything is in feet. And that I rounded, right? But approximately. So the area we need to paint is really big. You'll notice if you're looking in the book on page 605, which I should have said before, page 605, the example there, we go back to this, says 579.47. So we rounded, and then here we are. Okay. So we can combine all sorts of things. This was a fairly complicated shape because it had a big rectangle and then two pieces inside that we had to cut out. We measured those and then subtracted them from the total. We can do other things like if you're trying to measure a baseball field or just the outfield on a baseball field. you would measure the whole thing because it's just an arc of a circle. Well, usually not perfectly because baseball fields are weird. You do the arc of the circle, 90 degrees. It's a quarter of the whole circle, and then you would subtract the bases area, that square, from the total, and that would give you just kind of the outfield outside of the bases. That's not really how they measure baseball stuff because baseball fields are not perfect squares, but that's an example of the way that you do it. You might also need to measure, if you were just measuring street area in your city, you would measure the total area of the city, and then you would subtract, like on a map, and then you would subtract all the plots of land where there's not streets. And so that would give you just paved roads. Stuff like that. Okay? So the idea of subtracting is really important. Okay, we have about 10 minutes. Lucine asked about going over the problems I assigned. Now I need a minute because I don't remember which problem I assigned. So hold on, I will look it up unless someone wants to tell me in chat. Don't have it off the top. Okay, that's that section, basically. Can you use tracked areas, find pieces of areas, and then using a sector to, am I dropping frames? No, just fine. Weird. Thank you, Lucy. So what is this? Lengths. So when we're doing this, I may go a bit faster than I do in class because one, I don't have your faces to base my pace off of, and also you can go back and watch the video, right? So that I think is valuable for you. Let's see, I did it 3 through 10. I don't think I'm going to do 3 through 6. Those are the easier ones. 6 says exact, so the thing about that one, number 6. Oh, this one. 6 says exact, so it means keep it in pi units. So 2 pi r, right? The diameter is 5, so it would just be 5 pi. Number 6 there is 5 pi. So this is a review from last week. It's page 598, 3 through 10. So number 6 is just 5 pi inches. Oh, I am not on the right thing. So there we go. So number 6 is 5 pi inches. This is a hashtag number 7. Really bad one. But, so 5 pi inches. Then let's see. Arc length of AB, we would do 45. This is number 7. 45 over 360 times 2 pi times the radius, which is not 8, it is 4. Radius is 4. So number 7 looks like this. And the total length is 8, so the radius is only 4. And then we plug that into a calculator, and we get some number. I don't know what that number is. I think I'm just going to set these up. Yeah, Naomi, I will have that. I already have one from like last year that I can just give you guys. Will you have to take a final? I might assign something that feels like a final, but remember your grade is based on quarter 3. So any work that we're doing like this, it's not mandatory. It won't change your grade. Or it won't bring your grade down, right? So stuff I assign, I might say, oh, this will be extra credit if you do this. Will only bring your grade up. Okay. And we might do some Khan Academy assignments and different stuff like that too. Let's see. Back to that. Then number 8 wants to find the measure of DE. So that's asking for the angle, not the arc length. It has the arc length. The arc length is, notice this number, 8.73 equals, we don't know what the angle is, divided by 360 times, the radius is 10, so 2 pi times 10. That would look like this. So we know the measure of the arc. The arc is this much. Theta we're trying to find, divided by 360 times 2 pi times 10. I should have done on Thursday. We'll do the review first, and then we'll do the next one. Okay, and then we would solve for theta here, the angle. So we would multiply and divide. So we would get 360 times 8.73 divided by, right? This is division, so we do the opposite, multiplication, which puts it on the top on this side. And then divide by 2 times 10 times pi, and that's going to give us whatever theta is. Okay, so we got to rearrange it. Number 9 just wants the circumference. So let's see. Where is this? So our arc length 7.5 equals 76 over 360 times. Now, normally you would put in, here's what I'm doing for number 9. The arc length is equal to the angle divided by 360 times the circumference, right? The total length. So normally you do 2 pi r. We don't need to find r, we just need to find out what the total 2 pi r is. So I'm just going to use c. So here we would cross multiply and keep c over on this side. So we're going to equal c. 360 times 7.5 divided by 76 would be where c is. And you put that in calculator. Okay. And then last one, I'm going a bit fast because we're getting this to we want to find the radius. So that's like the next step from number 9. 10. We've got an arc length. Now you'll notice number 10 uses the big angle instead of the small angle. So here's that one. Nope, sorry, did switch it. Here's what we do. We do arc length 38.95 equals 260 over 360 times 2 pi r. And then we need to solve for r here, the radius. Let's see what squiggly puts it in that way. What we would do is we would multiply and divide. So 360 times 38.95 divided by, we multiply by 360, multiply this by 360. We would divide by 2 pi and 260, 2 pi. And this is going to be a radius. After you put it in. I'm not going to put any of them in the calculator. You can do that, right? I'm pretty sure the answer is wrong. On the internet somewhere. I'll find it. Okay, that's that. Sector area today, using kind of the same thing as this. This is arc length. Kind of the same thing as this. Here you would use this ratio, and instead of the circumference, you would use area. The same thing. The practice that I want you to do, we will look at right now. We'll do 2 sets of practice problems. Because you have, remember, you got an A. You're only doing these because you're bored and want to do math. Not bored, but if you want to keep learning math. I'm not going to put them in for a grade. So, this is the old practice. The new practice, the old practice is 598, 3 through 10. The new practice is going to be page 606. Seven through, no, 5 through 8, and 15 through 18. So normally in a lesson we would, or like if school was happening, we would have done like half the lesson that we did today, one day in class, and half the other day. This would be, this 606, 5 through 8, 15 through 18 would be the first day's homework, and then the next day would be this homework. I think we'll do less probably. Page 607. And then this will be about shaded region areas of regions, pieces of things. So you're going to be like subtracting and all that kind of stuff. 23. Oh, okay. So that'd be like 2 homework assignments. Now, remember, they're not homework, not very grade. So those are the view. And they look like this. Now, if you have any questions, ask them in the chat. I'm going to give us about another minute or two, and then I'm going to reset the stream for algebra. No puppy today, but it's outside. Okay. Hopefully that was helpful. Questions that I had seen. Final? I don't think that there will be a final. Yes, yeah, take the pass. Don't forget the pass when you go. Review, yeah, I talked about that. I should have one. I'll put it in the Dropbox eventually when we get there. And I think that's it. Yeah, so I'm going to sign out. I'll see you guys again on Thursday, and we'll talk about some more math stuff. And hope you have a good quarantine.